everyone, today in this video we are going to show you what is gas chromatography. Okay. Before we moving into the deep explanation of gas chromatography, let me give you the definition of gas chromatography. Gas chromatography is actually a chemical analysis technique that is used to identify and also quantify a compound in a mixture based on the volatility of the particular compound. I think you guys are still blurred. Okay, don't worry, stay tuned in this video.
How gas chromatography works? First, you have to inject the sample into the box. Although you inject the sample inside the box is in liquid phase, it actually evaporates itself into gas phase once it enters the box. The different color that shown here is actually indicates the compound that appear in the mixture. Let's say the blue one is compound A and the red one is compound B. Therefore, it has two compounds in the sample. We need a mobile phase which is inert so that it won't react with the analyte to form a new chemical to push the analyte into the box. Once the analyte is pushed into the box, it will stay inside the box and vaporize at particular time. And when it vaporizes, it will send a signal to the detector, and the detector will actually interpret the data and send it to computer, and the computer will actually represent it in terms of graph, which is shown like this. Here is retention time, and here is the signal, and it will show like this. At different retention time, you will have different compound that can be found in the sample. And the area here is actually determine the concentration in the sample. So that is how the GC works.
At the second stage of the process of gas chromatography. First, let's just assume the red dot is compound A and the blue dot is compound B in the sample. The longer the coil, the higher the efficiency of the detector to detect the data. This is actually what happens in the box. As we can see, there are liquid coating on top of these two surfaces, which actually serve as the stationary phase. Compound A and compound B will actually be pushed by the mobile phase, which we call it analyte, to the end of this coil and then to the detector. But the problem is, which compound will actually reach the detector first? So we proceed to the second stage. As we can see in the second stage, compound A is much more further away compared to compound B. This is because compound A is much more volatile compared to compound B. In other words, compound A are much more readily active to change itself into vapor state compared to compound B, which compound B prefer to stay in liquid phase. So, therefore, compound A will proceed to the detector, followed by compound B.
A graph of signal versus radiation time can be plotted to represent the data. For two compounds, normally 3 peaks will form to represent data. In this case, the first peaks represent the solvent, because the solvent has a low boiling point red dots, which is the component A, reaches the detector faster, which means it turns to vapor faster compared to component B. This is because of the higher volatility compared to component B. Finally, this tick represents the component
What if we have two compounds that have the same boiling point? Will it work in gas chromatography? Well, the answer to that is yes. Let's see here. We are assuming we have two compounds. Compound A, which is much more smaller than compound B. When the mobile field moves towards a hole to the detector, compound A, which is relatively small compared to compound B, moves much more easier. Let's take an analogy of a sumo wrestler with a kick. When both of these person is being blown by the wind, the kick tends to fall back easily compared to the sumo wrestler because of the difference in weight and size.